Hello, everyone, and welcome to Auth Part 1, Creating Users. So this is going to be a three-part series. We're going to do the first one today. By the end of this lesson, you should be able to create new users in Rails. And you should be able to explain how hashing works. Just as a preview, the other two steps are authenticating users, and I don't have the third one on here yet, but that will be protecting resources. So you can do all three of these things. You can do auth in your app. And you can personalize it and do all kinds of cool stuff. So let's talk about how we create new users in Rails. This is actually super simple. I want us to get this under our fingers so we can do it. Just fire it off every time. All you need to do is create a route to create a user, create a controller to create a user, and then create a user model with a secure password. We're going to do each of these. You're going to watch me do this, then we're going to do it together, and then you're going to do it yourself. So you're going to do this 3 times. You should be a master of this by the time that we're done. Are there any questions before we get started? First thing I'd like you to do is navigate to an empty directory and Rails new --API. Somebody give me a noun. What are we going to call this series?
Pigs.
Was it?
Pigs.
Pigs. We're going to call this Piggy Bank. Yep. RVM use 2.6. All right, Rails new API, Piggy Bank.
We're watching you do this right now.
You're watching, well, you can go ahead and get this this part of it done. Good question. But yeah, you're going to watch me do it. We're going to do it together. Then you're going to do it on your own. So this first step, creating a route to create a user. Nothing special there. We know how to create routes, right? What do we do? Params G route, yep, you can do that. If I go into the router file, what am I adding? Resources users. And then any guesses what HTTP method is going to create a user? That's simple. It's like you could teach a lesson. And then we need, what's the vocab word for this? We're creating a controller that goes along with this. And then like the actual method that we're writing, anybody remember what that's called? So if we do if we route to it, we route to the user's controller. We're routing to what part of the user's controller? Starts with an A. It's a method, but it's a special name in a controller. Uh-oh. Let's review. So we have an HTTP request that comes in. What intercepts the HTTP request? Router. Good. Router's job is to take the method and the path from this method and path and map that to a controller and an action, the word I was looking for. So we go over to a controller, which is made up of bunch of different actions. These actions will often either read from or write to what?
Database.
Correct, via models. Different actions can use the same model. And the model is how we interact with the database. And then these actions also generate HTTP responses. Request comes in, router matches a method and a path to an action on a controller. We find that. This does whatever it needs to do with the model. Model does all of our database magic, generates a response. That's basically every Rails app is some variation on that. Questions about this so far? Cool. Let's check out Piggy Bank. So I'm going to make a server and an editor. I'm going to Rails S. And let's make sure that I did in fact wire this up correctly. Localhost 3000. Cool, I'm on Rails. Step 1, routing. So I go over to the routes, resources, users, but all we're doing is creating, and so how do I narrow that down so I don't end up with like 6 other broken fucking routes? Includes? Only. Only is an array of all the things that I want to do. Cool. God, now I'm getting self-conscious about this. Is it users or user? Are routes singular or plural? Let's look it up.
They're plural.
Okay. I believe you. Let's double check. Resources. Yep. Fact. All right, so we have done step 1. Really that easy. All right, step 2, creating a controller to create a user. So now we need a user's controller. I can do that with Rails G controller users, plural. If I go over to my users controller, what's the action call that I'm making? Create. Cool. And so then in here, I need to read in the user parameters, create a new user with them, send back the created user. Cool. So we can't do all that until we've done some of the other things. So we're going to create a user model with a secure password. I'm going to say Rails G model user, singular. Neat. This made the actual model file and a migration. Let's head over to that migration for a sec. So let's say a user has a name. They might have an email. They might also have a username. Point being, we can put anything we want on here. This is just like every other time we've done this, except One difference. This is where some of the auth magic starts happening. We make one called password underscore digest. It has to be called exactly this. Password underscore digest. Everything else, call it whatever you want. That's all your shit. Password digest is a magic symbol. Call it that. All right, so we've done that. We're going to run our migration. Rails DB migrate. It's done. And then we go over to our model, which is in models user. This is another magic thing. It's built into Rails. Has underscore secure underscore password. Has to be exactly that. It's a macro. This adds all the shit to the user model that makes this work. All right, so we had name, email, username, and password digest. So we're going to read in these user params and create a new user with them. So we can do something like user.create, let's see, user equals user.create, and then name is params.name. Email, username. Now, this part's where it gets tricky. Password, not password digest. Password. So we make a new user, we pass all this shit in, and then we send back our created user. Render JSON user. Ta-da!
No commas at custom, but no trailing commas.
No what?
Trailing commas.
The trailing comma.
Oh, that's allowed in Ruby. I'm 90% sure.
So you don't have to do like params.
Yeah, let's say I wanted to reorder these. Cool, they're in a different order now. I didn't have to also move a bunch of commas around. That's the benefit of trailing commas. But that shouldn't throw an error. All right, so time to test it out. We go over to Postman. And I say localhost 3000 users post. Then over in the body, let's send over some JSON. Name. Kyle. Username. Kyle Coberly. Email. Kyle.coberly@flatironschool.com. Password, not password digest. My actual password. Nice try, asshole. Anytime I have to create a student account or something like that. I've seen you people do auth before. I'm putting the actual password in there. All right, so I've sent this stuff over. I send it over, and I break something. Let's see what I broke. Oop, I need bcrypt. Beep, 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 beep. If I head over to my gem file, here's missing something. We need to uncomment bcrypt. I'll put that in the steps. And then, since we've changed our gem file, we also need to bundle install and restart our server. right, let's try that again. Undefined method name for action controller and create. Oh. That's what happens when I go back and forth between all these stupid languages. Hashes, not methods. All right. Now, when we try that in Postman, cool. I've created a user. Ta-da. Now, a thing I want to call out, though, password digest. What happened to nice try asshole? Furthermore, if I hop into the database, let's see, this was SQLite 3, DB, development, select all from users. There's my ID, 1, my name, my email address, my username. Where's nice try asshole? More on that in a sec. That's all our steps. That's everything we got to do. Questions so far? Pretty easy, right?
What's your model integration file?
Yep. Has secure password. That's all we got to put in there. And then that was our controller. Mez. Cool. Bang rang. Let's do it all again.
So we can obviously still do Rails G resource, just make sure we have password digest.
Correct. Yep, if you want to do it that way, I ain't hating. Okay, let's do another one. Rails G piggy bank to Rails new, right? Good.
API.
Yep. And I need to be in the right. God, I'm just all over the place. RPM use 2.6. Make it an API. Piggy bank 2. All right, we're gonna go around the world on this one. Here I am with a empty project. Stacy, tell me first thing I need to do.
Are you in it already?
I am.
Okay. So we need to, make a route.
Mm-hmm. You can do that. So I go routes, and then Adam, what am I typing in here?
Resources, users only, and our create method.
Beautiful. Diana, what am I doing next?
You need to do Rails G controller
Cool. What's it called?
user.
Plural. Okay. Very nice. Samantha, what am I doing?
User controller, you're gonna do your create method.
Mm-hmm. And then, cool. Ben, what am I doing next?
Me?
Yep.
Oh, user, first one's user params dot create,
Okay, so user equals user.create.
then, username.
Sure, let's take in username.
Params,
No, let's just do just username and password this time.
yeah, password, and then password, params, password.
Very nice. Mez, what am I doing next? Okay, so we got a couple different directions we can go. I can send it back here. I can start working on the user model. I can make sure that I have the appropriate dependencies. Any of those are fair game for next step. All right, let's bail Mez out. Yeah, Jess. Sure. Mez, what's that going to do? Render JSON user. Yes, that's exactly what it's going to do. Let's expand that as a class. What do we mean by something with a string?
When you send it to your browser, it can only HTTP requests only do strings, so JSON stringifies it.
Basically, JSON stringifying would be the JavaScript way of doing that. But HTTP requests, it's not even strings. It's just a fucking bunch of characters. And so we take our bunch of fucking, our complex object, our instance of a model, and we turn it into a bunch of fucking characters and send it back down. Seth, give me a thing I can do next.
You can uncomment decrypt.
Yep, I like it. Let's go over to the gem file, go down to bcrypt, uncomment it out. And then, Seth, what else do I need to do to make this work? I uncommented it, but I also need to do two things.
You need to bundle itself.
I do.
And now restart your server.
Yeah. Dope. Amy, what am I doing next?
Where exactly are we? Sorry, I went to the restroom.
Oh, no problem. So we have our controllers in pretty good shape here. We have the dependencies we need. We have the route. What's next?
Your model. Did you guys do the password?
Nope. Haven't done anything with the model yet. So what do I do?
So you do Rails G model user.
Love it. All right, Jess, give me the next step. We have not. Okay. Has secure password. Yeah, why not? Okay. Very nice. So we'll say username oops, and password digest, and then Adam, what am I doing here?
Migrate.
Gotta do the migration. Yep. Rails G, come on, man. All right, so donezo. I'm running this on 3000. Let's see if it worked. So go over here, go over to the body. I don't really have a name anymore. I'll do an email anymore. Send it. Done. We have successfully created a user. What questions do you have about any part of that process?
Can you just really quick go through the routes, the controller, and the models?
Yeah.
So,
But
So I'm going to read in the username and password that I was sent. I'm going to use them to create a new instance of this model. Part of the magic that has secure password does is it goes, password, you say? I don't think so. I'm going to store that as a password digest. Has secure password just does that translation for you. You give it password, it turns it into password digest. Saves that in the database. Our resulting object we render back as JSON. What else?
Is it in the model that we write the password digest?
We write that in the migration. The migration, this table is storing a username and a password digest. We can also store any other things that we want about the user. Hair color, age, normal shit that we do.
I thought in the migration file we put that has secure password.
That's in the model file. Model has secure password, migration has password digest. Yeah, Ben.
Do the username have to be it?
Yeah, you can do all the same validation stuff that we've done. You can do that in the model just like you did before.
so with auth, I'm assuming like this is always going to be user is going to be the name of this model. And
Could be
be, yeah.
profile.
Okay.
Uh,
Or at least like to be sensible about it, you'd always name a user.
something like that, yeah. Cool. What else? Awesome. Nothing to it. See if you can do it on your own. Look at your notes as little as possible. Really wrestle with it. See if you can do it without notes. Don't hurt yourself, though. If you don't got it, look at your notes. I'm going to put 6 minutes on the clock. Throw up your hand if you get stuck. Yeah. I'll know you got this when I'm looking at your Postman screen and I see your returned user. ERB is that a template? That's the thing you skip with you guys. That's kind of dead. But you do that instead of React or instead of HTML, JavaScript, CSS. Just do it all in Rails.
Because it's easier, right?
So is Laravel. It's how all this stuff used to be done like 3 or 4 years ago. See, when you do that, you don't have a separate front end. The Rails thing is your entire app. It just generates those HTML pages.
got it?
Yep.
Cool. Over to Postman. Post users. Body is turned over. Yes, we want username and password or whatever you. Oh, you can't do it in the browser. It's just the post. That makes sense. And then back in your model. You don't need to add anything to the model here other than that's the password. And then we good. Is this your form? Beautiful. Good. Let me see your migration. Beautiful. Did you want?
I did run the.
Okay, cool.
Right, the server.
Alright, so if you username and password in here. That will do this. And then both of those need to be read in for the codes. Yeah. Cool. Then do Tom. Perfect. All right, fire it off. Sure. Let me see your migration.
All right, questions about that? Let me show you briefly how this looks in Node. It's not really any different. If I go over to this backend, all right, so my create users controller. Since it's Node, you have to do everything manually. Of course you do. We read in the stuff from the request. So we routed to a controller. It's happening. All right. We read the parameters out of the body. We hash the password. Then we create a user. And then we give it back. Same thing. Universal process. So that is creating new users in Rails. The other thing that we want to be able to do is explain how hashing works. This is that has secure password magic. That's password digest. Hashes. Hashes are a kind of neat math thing. Let's say I've got the string cab. And I turn this into numbers. 3, 1, 2. And then I add them together. So I get 6. In Kyle's shitty hashing algorithm, I could say that the hash of cab is 6. It's not an encryption. It's not an encoding. I can't know that cab was the thing that I was originally given. I can't work backwards from 6 to cab because if I did ABC, I'd also get 6. In fact, there's all kinds of different things that in combination would hash to 6. But if you gave me cab again, it would also hash to 6. That's Kyle's garbage hashing algorithm. If we look at the bcrypt algorithm, let's see. See if somebody will give a walkthrough of it. Yeah, it's a history behind it. All right, so it has all these different phases. And it just takes, it's usually like a bunch of like rotations. Like, all right, so we turn all this into numbers, and then we move everything up, and then we sum it, and then we take the original value, and then we do this other thing, and then we sum those two, and then take the square root of those two things. It's designed to be very, very difficult to intentionally get two different things to hash to the same value. Even though they could, every single hashing algorithm has this problem, where these two things hash the same values. With bcrypt, there's a better chance that like all of the atoms in the universe will collide at the same time, causing us all to just burn up in a giant nuclear explosion than there is for you to intentionally be able to hash two things of the same value. As you've seen, like these hashes are pretty complex. It's also designed that if I give you a, check this out, it's kind of cool too. If I give you a 1-letter password, gives you a hash that's the exact same length. You can't even tell how long my password was. And last cool thing about how this particular kind of hash works is, all right, so K, or what was the password for this? A. A produced this hash and ended in DD6. A turned into DD6. All right, well, I make P, also give it a password of A. Hash doesn't end in DD6. Fucking wild. And it does that because of a thing called salting. So this is hashing. Salting is if I randomly generate some characters, tack them onto the end of what you gave me, and then hash that. That's hashing and salting. So I write cab, and then I add 61E. I combine these two things together and then apply Kyle's shitty hashing algorithm to that. So then if I have cab as my password and Toby has cab as his password and Ben has cab as his password, if you crack mine, you don't crack all three of ours. You can't even tell that we have the same password because we have different salts thrown onto the end. And what's cool about it is you can know what the salt is ahead of time. Doesn't do you any good. Doesn't get you any closer to figuring out what the eventual hash value will be. And the reason that matters is like certain passwords are used more frequently, right? Password, 1, 2, 3, 4, 5, 6, 7, Blink 182. There's like super common passwords. And in fact, you can even study how frequently they're used. And if you get a database of hashed passwords, you could look at how frequently certain hashes show up and compare those two things, and all of a sudden you know what a lot of people's passwords are. That's called a frequency attack. You just look at the frequency distribution of how often something's used. You're like, okay, even though I can't like actually decode this, I have my guesses. And so if I salt it also, good luck. You have a database of hashed passwords, you're not going to figure out what those passwords originally were. Cool. Questions about this so far? Some important things to keep in mind. Hashing is one way. I can turn cab into 6. I can't turn 6 back into cab. Hashes are intended to be unique. They make, like, I may have cab and you may have ABC. We might have two things that have the same hash value, but it's not intended that you can intentionally trick some algorithm into logging you into somebody else because you can engineer your way into having the same hash. Not how it works. Salt further hides the original value. So if I have cab and Toby has cab, we don't have the same hash for that because we have different salts. In fact, the way this password digest works, there's actually a lot of like information encoded in this. You're saying, I'm using the second edition of this hashing algorithm. I want a cost of 12, which is how long it takes to calculate. This part up to the dot is the salt. And then this last part is the resulting hash. So if you add this salt to nice try asshole and use the second edition of the algorithm at a 12 cost, you should end up with this value.
But even knowing that, there's no way to reverse engineer it.
Yep. I can't get back to A or nice try asshole or whatever from that. So what good does that do us, and why the fuck are we talking about this in the creating users lesson? What do you think it does?
Make a secure database.
Okay, so nice try asshole didn't get stored in the database. How does that help us down the road? When I put nice try asshole into my login page in the next lesson, how is it going to know that that's my password? It didn't store it. Mez.
Is it going to hash that one and compare the two hashes?
There we go. If you take the nice try asshole that I do in my login page and hash that, it should be the same value.
So when you're logging in for the first time after you created a user, how does it know which salt is right?
Because the salt's in the stored hash. It's this part right here. So I type in nice try asshole, I send that over to my server tacks that onto the end and hashes that and sees if it turns into this.
Because it's finding the right user and then adding the salt and then, okay.
Correct.
So then if
Yeah.
you didn't have like unique usernames, the salt also helps like differentiate between, okay, well, this username has this hash and this solve, so this is their page versus,
You wouldn't do that. You'd want like your usernames to be unique or some part of this to be unique. There's like games and stuff where your usernames don't have to be unique. Two people can be Darth Maul or whatever. But you need to have a unique email address or something like that. And so then I'll give you a preview of the next one. Step 3 for this is you need to look up the user. If the user doesn't exist, bad username. If you look up that user and their password hashes don't compare, then it's the wrong password. Yeah, Seth.
So why do so many websites tell me one or the other is wrong? We don't know which.
Ooh. That doesn't have anything to do with this, but it is important. Why would a website not tell you that it was your username was wrong or your password was wrong?
because then if someone's trying to hack into your website, they could be like, oh, well, the password's wrong, so I'll keep fucking around with this.
Mm-hmm. Otherwise, they don't know which one it was. So that's just like that's like your lowest level cracker protection is like, why would I give you information that further helps you attack my database? Yeah, there's kind of like a perpetual fight between user experience and security. Perfect example of that is 12 cost. The higher this number goes, the longer this hash takes to do. Not that big a deal when you're creating an account, but when you're logging in and we have to rehash this stuff, that's longer and longer and longer that takes. And so when I started out, 10 was pretty standard. And then as processors get faster, the easier it is for a cracker, because there is ways that you can try to recreate hashes. They're called rainbow tables. That's a story for another day. But they rely on how fast your processor is. And so each one of these like steps it up another level. It requires more and more and more processor time. But over time, you need to keep stepping that up because your computers get faster, so this becomes more reasonable, and their computers get faster, so they can crack more. So you're trying to maintain an acceptable enough user experience while also remaining one step ahead of the crackers. But yeah, the rainbow table attack thing is basically, since you can't reverse this out, you do it the other way. You go, does this generate the hash? Does this generate the hash? Does this generate the hash? And you just do that billions of times and try to find. So like if you did get a compromised database, NBD, they don't have your password, but you can try to do a lot of things to recreate this hash and do it that way. Cool. Other questions? Yeah, Seth.
This is probably going on part 2, but how do you start requiring certain characters, certain lengths, those kind of things for a password?
It's not in the next lesson, but you already know how to do that. Oops. I'm in the wrong thing.
That'd just be validation.
That's literally just validation. What's the validation keyword?
For what, length? Or
For any of them.
Validates.
Validates. So we can say something like validates password and then just pass in whatever other shit we want in here. Is like length min 7 max 20. All of the regular model validations that we already know how to do, we just do them here. Validates username uniqueness true. Cool. Now you have to have a unique username. And another thing we didn't go over, but can also do is in this controller, you try to create the user and it's not a unique username. Well, you can get the errors that generates and send those down as JSON also. Other questions?
On like websites where you like change your password, it's like you use this password in like the last year, is that a validation too of some sort?
No, that's a different level of it. So at that point, you're overriding something like has secure password. Well, no, I guess you wouldn't have to. You could say, all right, I'm updating the password, so I need to rehash the one that they gave me, and I can keep an array of like every hash that has been previously used and do like, all right, does the new hash, does this array of every hash they've ever had, is this new one included in that? And if so, then it's a reused password. Good question. What else? Another thing I want to call out here, that's how easy it is to store a secure password, store a digest. And like even in the hard one, when I was showing you the node one, it's a little bit more involved. Cool. We hash it, we give it the thing, we give it a cost. That's it. Now you don't have to store plain text passwords anymore. So think about that the next time you see a data breach from a company like Home fucking Depot that has more money than God, and that's what they're fucking doing. It's not hard. You just have to care.
Disney Plus.
Indeed. Cool. Thank you. Part 2 tomorrow.